Okay, we'll start with Kerberos. Kerberos is like it's a authentication mechanism. You can have protocols also, Kerberos protocol. Like once you made a request to any to authentication, like for AD. So what happens is you will be requesting for authentication. Okay. Then the server will ask for password. Okay. You provide me the password. So then client will supply the password. Okay. This will give you this ticket. Okay. You take this ticket, and then after authentication, this ticket it will take that ticket and ask for granting permission. Okay, you give me access so that I will go and access the applications. That's how Kerberos will work. So here, if you see here, you will have a KDC here. That will be one role in Active Directory, key distribution center. Okay. So you are requesting the ticket. Ticket plus the domain controller will give you ticket plus session key. Okay. You will have a session. You go and log into that server. The session will be valid, even if you just do the remote desktop. You logged into that server and just have what do you call you close the remote desktop. Okay, you will have some what do you call that, remote desktop manager. You will just right click on that, and just if you connect it, it will connect automatically. Okay, because you will have a valid session key. Okay, so still in this initial phase you are getting the token. Okay, your request ticket plus authentication. Once you got ticket and session key, you will have access. So the authentication process itself will take all these mechanism at back end. At the last, in the last phase, you will be allowed to access the server. This is a Kerberos mechanism. All are similar diagrams only. So how we do the three-way handshake, right? In similar way, it will have a ticket, then it will ask for a session, then it will have a session plus authentication key. This is how Kerberos will work. Authentication plus ticket granting server. Okay. So you have to get the ticket, and then you need to respond with that. Then the ticketing will grant it for the server ticket, client server. Okay. Now with that ticket, you are going to access the all with your domain credential. You will access the server resource, or you can have a resource server. That's the authentication. See, you are requesting access to the server here. Okay, I will take one example here. So this is my laptop or desktop or my Windows server. I am trying to log into this server. This is a file server. Okay, this is a desktop or a server, you can call. From here I am trying to log in. So what I am doing is I am putting a domain credentials. So this is my AD. Always AD will be in triangle. Okay, this is AD. So whenever I am trying to put the AD credentials. I am trying to log in here. Okay. Back end, this is happening here. You are putting the AD credentials. Back end, you are getting the tickets. So once you have authentication services, server is authenticated here, your credentials are validated, then you are allowed to access this server, or else you need to log into local user and password, local username and password. Once you have local username and password, you cannot have domain services. You have file server, DHCP, print, everything will be on these objects. So you will not have access to those AD resources. Only local resources are allowed if you don't have access to domain. For domain, you need to get these keys and from the KDC, Key Distribution Center. Now it's clear. Same. All diagrams are same. So we will see on this authentication part, like TACAS and radius. So do you have understanding on these services, Danish and Shamsher? TACAS and radius. Yeah, what is that? Can you explain us, because you will be knowing much details on this.
I don't know. You not about this one.
Okay, TACAS you don't know, right?
No, not so much.
Okay. How about you, Shamsher?
This authentication and three-way handshake, little bit confused for me.
Okay, we will see why we will use TACAS and radius. Okay. TACAS and radius, we do use it for at switch level, at network level. We are not bothered about the user authentication. So that will be done at the network level, network device. Okay. So your network device will have to authenticate it. So either you do with UDP or TCP. Let's say here in radius it will be UDP, like it is there will be no handshake. I am just giving my credentials. You need to provide me access. Let's say I have a network device here. If it is radius, I will just request authentication. Okay, you allow me to enter, or you allow me to communicate to this switch. Okay, I am coming from outside. This will ask, okay, you give me password. Okay.
To manage your Google account password, tap Password Manager below.
See, this is being recorded. My mobile phone is telling, okay, if I am talking about password, Google is asking me. Okay. So once you provide this password authentication, it will reply, okay, whether you are allowed or not. Then you will have authorization. Okay, you go and you will have authorization level. This is how normal radius will work. TACAS is Cisco proprietary. Like you can have filtered here. So it will be TCP. means you will have a handshake, three-way handshake. It is you need to connect it. Okay, here it is UDP. You are just connecting that. That's the difference between TACAS and radius. So both are what do you call, at network level. Okay. So this is for TACAS. This is the difference between TACAS plus and radius. Okay. AAA, authentication and authorization. So we are combining both here. Okay. You are authenticated means you will have authorization also. Okay. You can go and have access. Okay. I am least bothered. I am going to control you at OS level. I am giving access at network level. Here you will have all those functionalities, like you will separate authentication, authorization, and there is one more A. Authentication, authorization. What is the other A? You need to see what is the other A. You have AAA. Okay. Protocol here is TCP. Here this is UDP. It is connectionless. This is bidirectional. This is single directional. Okay. Here you have completely packet is entire packet is encrypted. Here only the packet password is encrypted. Yeah, if you see here, at TACAS you will have port 49. In radius you will have UDP ports. Accounting. Okay, the other A is accounting. Authentication, authorization, and accounting. So we are separating all these in TACAS. Whereas in radius you are just allowing it. Okay, let them allow it. Okay, here only passwords are encrypted. Here you have.
You said TACAS is a Cisco product, right? It will be used only in Cisco.
Yes, it is used in Cisco devices.
And what about if Cisco doesn't use Redis?
See, they will what do you call that? They will market these what do you say? This control, okay, these additional security layer. They will ask you to utilize my security concept. In the radius, you will get it in any default routers. You will not get TACAS. So the marketing strategy, they will use it with like you can use my proprietary tools like that. Services, authentication settings. Where is TACAS here? I can have like radius authentication because this will be allowed. This is the password. This is the challenge. CHAP or PAP. This is challenge handshake protocol. PAP is password authentication protocol. So which one you want? Okay, local authentication. Okay, if someone wants to access my server from outside, I can enable this. I just have a radius here. That welcome information you get right when you type that information, the copyright message, logon preview, all that stuff. So I am sending it to any radius server inside my network. Okay, if there is any radius server or secondary radius server, these are authentication, all that stuff. I don't have here Takas here, because Takas is proprietary. So if Cisco is not promoting it, okay, then we don't have the extra security granular control here. So if we go into these settings, you will have much more control in configuration in Takas. So this will be at the network level. Okay. Let's say I will have advanced. Remote desktop. Let me see. Remote desktop settings. Okay. So I have remote desktop settings here. I will ensure that show settings. Advanced settings. Okay. See here, require computers to use network level authentication to connect. Have you seen this one? Are you able to see my screen?
Yes.
See, if I uncheck this, what happens is anyone can connect. So what will this checkbox will do? I will show you with this one example. Okay. So I have one user here. Okay. This is my server. This is my router or Wi-Fi. Okay. If someone wants to connect to this my public IP, okay, this is my static IP. You can connect directly to my static IP. Okay. But what I am telling my system here at OS level, no one should directly connect to this. See, directly you are coming through router only. Okay, you are not jumping over the router. But what I am asking is, you get connected to the router here by any means. You do point-to-point tunneling protocol, or you use Open VPN or any other. You just get authenticated at network level first. Okay, once you are into my network, then I will allow you inside. That is what that checkbox is. You are just seeing it, the checkbox, but the checkbox will act like that. Okay. If I remove that checkbox here, okay, advanced setting. If I remove this, see, this is grayed out. So if I remove this checkbox, what happens is, you don't have to authenticate into my network first. For authentication, to get authenticated into my network, you should have VPN connectivity. I should configure here somewhere. You should be allowed to access my server. I don't have these in this VPN service. I don't have, or else I would have configured that VPN services here. Then you would be able to connect to this router or my load balancer, and it will allow you to connect. That is the difference between TACAS and radius. So here radius is very pretty old. It will be at the network access level. Maybe at switch level that will be configured. So these are all very old means of authentications. This is the latest one. You have Azure MFA. We'll go to the cloud one now. So from smartphone, we are accessing, let's say, one services. Okay. So from HTTPS, you are going back to Azure MFA. Azure MFA is going to MFA server. So for example, if you want to have access to remote desktop server, okay. So from mobile device you are accessing the resource. Let's say you are accessing with RDP port. You got this RDP, right? Remote desktop protocol. For Linux it is SSH. Here you are have deployed the network policy server, NPS. So where this is automatically getting authenticated with MFA. So you have a radius here, like once whoever reaches at this level, you get authenticated with MFA. So this user will be authenticated with that multi-factor. One with multi-factor and one with your credentials with Kerberos. So we just talked about Kerberos, right? So once this authentication is done, then you are allowed to access the remote desktop server. So for accessing my server, it is pretty simple. So here what they have done is, instead of this is my router, okay, this is the other user who is trying to access. This is the server, okay. I am splitting it so that it will be very easy to understand. So at user level, what we are doing is, we are checking with multi-factor authentication. One, you should know, you should have device. Two, you should have password. This is device and this is password, okay. So password, I am going to get authenticated with AD. Password will go this way. With MFA, you are still on to this mobile platform only. So I am going to access through the internet. Still it is internet. I have kept it in an encrypted way to MFA server. This is going in this direction. So once you are authenticated at this level, if you have passed these two levels, then you will be allowed to access like this. This is the mechanism. Let's say if I am having a radius server here, in my scenario, what I am going to do is, I will have a radius server here. So whoever trying to access my server, here my server, I will ask, okay, you connect to this radius server. You need to have username, password here. Okay. So once you are authenticated here, then you connect to this box. you need to have a username and password here also. So I will have separate user ID here and separate user ID here. See, I am filtering out authentication here. This is all the part of authentication. I am protecting my confidential data with implementing authentication mechanism. Okay, again this will it will come with all those topics that we discussed, like confidentiality, identity, CIA, and then non-repudiation, integrity, all that stuff. It will be coming over and over again with different terms and terminology. Okay, now we will be going to crypto tool, cryptography. We will go into cryptography. Okay, and see what is this tool. This will be very interesting. So here you have a sample cryptographies. Like I will take any one. Okay. These are ciphers. Ciphers means you can do this encryption, plain text, plain text. Okay. Between 1111. Okay. If I put that plain text, the cipher text will be 56. All with prime numbers, it will do that. So I will substitute or I will transpose it. So this is the original text. Okay. The cipher text is this one, unblocked. Okay. This is unblocked. So I will type hello. What is your name? I am fine. Okay. Blocks of 2. Okay. These are the blocks of 2. Blocks of 5. Okay. Code. So you can see that that is changing. Transposition key. That is being transposed. Like your keys will be changing. So I will explain you how this is going to work. Okay, I will just put single letter here. Okay. Double A. 2, 3. We'll put ABC. You can see now. ABC. So these are all encryption. The way you do this algorithm, it will work on this way. How you can do that? This is the common way of doing the encryption. So you have round 1, round 2, round 3, round 4. At the last level you will get that message. These are all standards. We'll see what are those standards. So just if you want to play, you can play with this RSA, symmetric, asymmetric. So plain text, what is plain text and what is clear text? So plain text is it is human readable. Okay. Clear text means it can be plain text or that data that can never be intended to transmit or stored in anything. Okay. Plain text, it can be, you can save it on any form. Okay. But clear text, we should not store it if it should not be readable. Okay, that's the difference between plain text and clear text. So this is just a little difference in it. So you have plain text, okay, then you have made into ciphertext, then you have converted into the same plain text using encryption and then doing the decryption. So whatever we are using, that logic, that is called as salt. So once you do the salting, you will get that hash value. So in the earlier classes in beginning, I told you about salts. So we'll see all those kind of salts here. Okay. Let's talk about how these encryption keys will work. So I have Alice and Bob communication. We will generate the putty keys. Have you generated any putty keys?
No.
Okay. See, I am generating SHA, RSA 2 keys. Okay. Number of bits in generated. Okay. I am going to generate these keys. Okay. So I need to move the mouse. Okay. If you see here, generate public and private key here. Okay. This is my key, public key. Okay. See, here I am typing the password. Okay. 1 2 3 4 5 6 A B C D E F. 1 2 3 4 5 6 A B C D E F. Okay. No, sorry. So we need to save that with that particular key. So if I share this key, then if you have a private key, you can get this authentication. I will save this as public key. Okay. Desktop. Put it as keys. Public key. I will put password 1 2 3 4 5 6. 1 2 3 4 5 6. Save public key. Password. Private key. 2 presses 1 4 5 6. 1 2 3 4 5 6. same private key. Private key, same public key. So I have public key and private key. Okay. Whoever has this public key, for pasting it into my authentication. So I will put this key in SSH. Okay. Let's say I have this SSH. So I will put this SSH. If you see here, Kuiper authentication. So I will put those keys here, private key for authentication. Okay. If I am connecting it to any server, so what you have to do is I will give you this public key, or I will paste this on a public server. Okay. If I have a private key, then only I will be able to access the server. Okay. So you will have a public key where anyone can see that text. Okay, public key. This is broadcasted. This is the public key, RSH, SSH, RSA. This is encryption standard. So this is our year, date, month and date. This is the format. So you are using this public key on your server or any server for authentication, and the password is, this is the secret key passphrase is this one is, we will call it as a secret in encryption standards. So you can have any other parameters also. This is number of bits generated. We can reduce this bits also. Let's see how this is going to work. You are now familiar, right? How you can generate these keys. We'll see. We'll go back to this. Okay. So I have Alice and Bob. So Alice has public key and you are sharing. If we want to communicate with Bob wants to communicate or send message to Alice. Alice wants to send it to Bob. So Bob will have public keys. Okay. He will attach. He will see with these keys. He will combine and he will send the message. Then Bob will do. What Bob will do? He will open that with his private key. So our private key will not be shared with anybody. We will not share it. But public key we will share it with anyone. Okay, if you are sending it, you just attach my public key. Only if you have private key, then only you can able to see that message. That's how encryption will work. So in data theft, what we will do is we are going to encrypt it with that particular user's keys. Okay. Only if you have private key, then only you will be able to decode that data. If you lost the private key, then your data is gone. You need to recover this with help desk. They will be able to recover your private keys. Okay. If I have
In WhatsApp also same method
What is that?
encryption. No, in WhatsApp and WhatsApp.
WhatsApp, you will not have a secret, shared secret. It is just a communication.
The encryption.
Encryption will happen. Okay. WhatsApp.
Because if somebody sends me a message, only I can read it.
Yeah, but I believe the encryption and decryption key would be with WhatsApp only. They can use it whenever they want.
See, they have public key.
That's also
Okay. User A, you are sending the messages to user B. Okay. So WhatsApp, what it will do is, we will take this one into our slide. Okay. So you have here public key. Okay, user, this guy's public key you have. So you don't know his keys. Okay, but WhatsApp server will know that user B's public key. He has the user B's public key. They will capture his public key backside. If you see earlier, you used to get some codes, right? Codes updated like that. Have you saw that?
no.
In earlier, they used to send messages like your code updated like that. So they
Yes,
were
yes, yes. Now also they are sending.
okay. What they were doing is they were updating your public key. Okay.
Okay, okay.
Back end they were updating your public keys. Okay. So that your mobile app should not get hacked. Okay. So with this public key, what happens is they will share it. Okay. You share the information with this public key. This guy has a private key. He will encrypt. He will decrypt the messages. So this guy will take this public key and transmit the data to WhatsApp. From here in that server, I am going to take that message and I will decrypt it because I have private key at my location. So this guy will not tell, okay, I am decrypting it with your private keys. This will work in seamless way. Like they will tell you, okay, this is end-to-end encryption. But still WhatsApp will have access to both these parties. That's why government is asking, I want to see the messages. WhatsApp will tell, okay, if I share this information, then there is no point in end-to-end encryption. I can allow you free. Okay, I don't have to do all this stuff. For doing this, you need to put lot of efforts. Like encryption, it will have a huge toll on your performance. Normal transaction, normal data will be it will be processed easily. But if you are encrypting it, you need to have a lot of processing. Okay, that's how WhatsApp will work. Now you got it right. This is Def, Hellman, Merkel, all these PKI. This is how it will work. Public key exchange, cryptography. This is how PKI or any other cryptographics will work. We'll talk about what is symmetric and asymmetric. These are all the similar way. Encryption, decryption, in all these are all different standards. How we will be encrypting that. So we'll have what is asymmetric and symmetric. We'll see that difference. This is GPG. Okay. Yeah. So you have symmetric and asymmetric encryption. Symmetric encryption is you have shared a key, like that's a password. Okay. And I will use that same shared key and I can decrypt the data. If I have a shared key, then I can access the Kuiper data. So whereas in encryption, asymmetric encryption, you need to provide a public key and private key. So with that you will have encryption. You can decrypt the data. That is the difference between asymmetric and symmetric. In symmetric encryption, it is done at the session level. Okay, your session will be encrypted at session layer. Okay, you got the session. Now you have entered. In asymmetric, that will be for authentication purpose. Okay, somewhere I kept that. TLS.
Wait, one small doubt.
Yeah.
While sending, plain text or whatever, the sender should have a public key of receiver or sender.
What is that? Shamsher, tell me.
No, for the message, for sending a message, the sender should have receiver's public key or sender public key.
So if I am
You are sending message to me,
okay,
so you should have my public key or your public key. How it works? Like, and I should have my private key or your private key. This got confused. The public key belongs to sender or receiver, and
Yeah, I think little confusing.
see,
this private key belongs to sender receiver. Can just
private key should not be shared. Okay.
okay. That means the receiver will be having receiver's private key, right?
Yes.
Okay.
See, if I am sending you a file, okay, or what do you call? So we will discuss this in detail in next class. Okay, I will talk about certificate authority. In that I will explain you how you will send that with respect to emails. You are talking about with respect to emails, right? Like you
whatever
will,
email or message or whatever for the communication.
okay, for the communication. Okay, so public keys, you will have my public key. Okay, that is easily broadcasted. I will paste this public key. Okay,
So
I don't have
if
any
I
problem.
If I am a sender, I will use your public key, right?
See, let's say I have this public key. Okay, so I am doing the authentication. Let's say this is purely authentication. So I will share this to entire world. This is my public key. So you take this public key, or I will paste it in the server.
So it will be open to the public.
Yeah, this is public key. Okay, you can read it anyways. Okay, to
Anybody can read.
yeah, to access my server, you have to decrypt this with your private key. Then only you will be able to access my server.
Oh, okay. Only if you have the private key can be.
Yeah, I will not share this. If I share this key, private key, then I am sharing password. Let's say I will open this with Notepad. Okay. This is how it will look. These are the private keys, encryption standard. This is how that private key will look. So if you have this data, then you will be able to access that particular server. You will get authenticated here. So I am adding here. These are all the configuration. If you see here, all these algorithms and all.
I don't have no company. You are the wonderful.
Kuipers. Okay. So these are the keys. Let's say you are sending this encryption. Okay. Symmetric encryption. Symmetric encryption will work on these algorithms: DES, triple DES, AES, and RC5. Asymmetric is RSA, elliptic curve, all this. So one-way hash we saw it in MD5 hash. So that will be one-way hash. You cannot do it in two-way. SHA1 also. These are all the encryption standards. Okay. So if you want to use symmetric keys, you will do with all these four encryption standards. Encryption and decryption will have the same keys. Okay. If you are using DES, AES encryption standards, if you are using asymmetric key, you need to use RSA or elliptic curve. You see just here, all are RSA and DSA. Where is DSA here? It is not there. So in asymmetric you have RSA, DSA and elliptic curve. So here we don't have that elliptic curve standard. With this you can generate that. These are all the encryption standards. So MD5 we will be doing at the file level. So these are the some of encryption methodology. Okay. Public key. This is elliptic curve cryptography. Similarly, this will be done. Okay, same like RSA only, but the standards will be different. Like the algorithm will be different. Okay. So digital signature. You have digital signatures, right? Whenever you are signing it or you are accessing that. Server based signatures. If let's say I will use this secure connections, more information, privacy. So here you have all these details. The page you are viewing was encrypted before being transmitted over the internet. Certificate. This guy, what he is doing that RSA public key. His public key info. He is broadcasting his public key. Means I am secured like that. He is telling me. Okay, you don't have to worry. So where he bought the keys from this authority. So if you are hosting any service or any server, people will see, okay, do you have any SSL services? Virtual engineer. So this is my host, okay, virtual engineer. If I type it, this is coming back to my web page, okay, where I have configured here. So I will log into my domain. Okay. So this is my virtual engineer website. This will be managing you, forwarding all these to my server. Okay. If you see here, I will have SSL here, rapid SSL. So I have certificate here, show certificate. I bought this from name.com. This is my certificate. If I want to host any website, if I put this is not secure, okay. You will get this one, right? It's secure or non-secure. Yeah guys, are you following up, or is it making complicated?
No, it's fine.
Okay. So my connection is not secure, okay. So Google will tell, okay, don't go to this site if this is not secure. So whenever you are doing hosting, or if you want to do any SEO kind of thing, search engine optimization, then you should have a secure connection. Yes?
SSL, right?
Yeah, SSL. Okay. This is my certificate. This is the certificate authority. Okay. This is my root certificate. These are all these certificates. Okay. See, if someone hacked this one, okay, certificate, what I will do, I will ask to reissue it. Okay. You probably don't need it to reissue this certificate. How to move your SSL to new. So they are telling me, okay, you lost the private key and want to re-key the certificate. So they are all asking about if you want to regenerate all these certificates. Okay. So we have done here like this, right? They will also do at the web level. That's how the certificates will have, okay, server based.
Costly, it is. They'll have to charge money for that.
Huh?
They'll charge money for that.
Yeah, they will charge money. See, I bought it to do something, okay, that never went off. I have bought this website for a long time. I try to start, but I will not be able to do that anything.
Oh.
Okay. So I am sending one message. M is sending message to message function, then it is being encrypted digest. Alice is the sender, okay. She encrypted it with the private keys, then she sent to Bob. Then he, with his private key, he will be able to access. Public keys will have, everyone will have a public key, okay. If you put username, they will be able to access that public key in the emails and other stuff. So with that, he will encrypt it with that public key. She is sending message with her private keys. Okay, I have encrypted it. You will have my public key. Okay, you take this and you decode that. So here Alice will have Bob's public key. So public and private keys, you just remember, like public and private keys has to be with the, if you want to decrypt that, you need to have both. Or if one user is sending it with one key, the other guy should have that public key. Then only they will be able to encrypt that. That's the simple logic. So this is all to protect your confidential information. In CIA, we are ensuring that the confidential information is being secured. Here, if you see here, she is writing a letter, converting it with the message digest, or like salting it with her private keys. So she is using her private keys and encrypting it to the sender using digital signature, and it is sent over the internet. So the guy who is receiving that will get the email. Okay, and using that public key, he will be able to decrypt the message. Okay. So what is SSL, TLS, HTTPS? So we just saw that SSL right now. In HTTP, it is not encrypted. You will not have a encryption standard. So whereas in HTTPS, you will have a SSL that will be secured. So at OSA model, this is again coming up. Okay. At the application level, you have SSL plus SSL and TLS. Okay. We'll see what is TLS in further. So again, if you go back, you have SSL handshake protocol. At the application level, you have all these SSL chains, all these stuff is coming up. Okay. So I don't want to go what is a handshake protocol. That is similar to our three-way handshake. That will be done at SSL level. Okay. So here at TLS level, so you will have encryption standard, fragmentation, authentication, all will happen at TLS level. So why we will use TLS, we will discuss, I will tell you tomorrow, okay, because that will be mostly used by Windows. Okay. So whenever you have any issues, if you are migrated into a new environment, you need to enable the TLS old version, then it will work. TLS protocol, you will have 1.1, 1.2, all that stuff. If you want, I can go back to here. Okay. TLS protocols. Now Mohsin is expert in reading books. Yeah, Mohsin. This is SSL handshake. Okay. I will put this all data in our share. You can see that. So I will explain you what is these protocols. Okay, you have older version and newer versions. That will be the standards, how you are encrypting it, at what level you are using the encryption. You can see here 1.1 official 99 SSL 3.0. Most of the issues will come when we migrate it. That will be automatically upgraded to SSL 3 version, and TLS protocol 1.2 or 1.3 will be upgraded. Then what happens is, like, your jump host will not able to authenticate because the protocols will be different. That will be using SSL 3. The old server will be on SSL 2. So it will be rejecting that authentication, like this is not matching. But you will not get that error, okay, this is not matching. You need to troubleshoot it, okay, at least 2-3 days. After spending that, you will come to know, okay, this TLS protocol is not compatible. Then you need to allow option to use TLS 1.0 version. This is just for encryption standards for the SSL. That's how the TLS will be used here. So SSL and SSH. So in SSL you will be securing browser and server connection. So for SSH you will be encrypting the communication between two computers. So this will be done on the networking industry. This will be done at the user level. So this will have public key and private key. Means this is asymmetric. Here also this is asymmetric, SSH. You have SSL VPNs and then IPsec VPNs. So we will discuss the remaining stuff tomorrow. Okay. If you have questions, you can ask me. Okay.
So the security administration administrators will have a privilege to the cases,
No, they will not have able to have any keys at all. That is completely individual. Keys are nothing but like your passwords.
So in my organization, I had my laptop got crashed. Okay, so my laptop was encrypted. Okay, so when I went to change my laptop, so what they did is that they removed my hard disk and connected to a different laptop where it was asking for a key. They had the key, encryption key, BitLocker encryption.
No, they don't. See, they are not security guys. They are help desk guys, admin guys. Correct or wrong?
Yeah, that is correct. But again, it was encrypted by the security software BitLocker, right?
Okay, I will tell you how it will work. Okay. So you have your laptop here. Okay. So you have here your hard disk. Okay. Your hard disk, you will have your keys here, your private key. Okay. So whenever you encrypt this, your private keys, they will have one server. So in that server you will have this private keys stored with your username, and with your username you will, that will be stored there. Okay, whenever you log in to this server or this laptop, you will go to this server and fetch your private key to read this data. You are not just reading it, you will have one application. What is that application?
Either BitLocker or
Yeah,
Cafe.
BitLocker, that will have a server, BitLocker server there. Am I right? Or you can ask that help desk guy, okay, how you stored my private key? You just ask him. It's a violation, all that blah blah. You just tell him okay, how you stored. He will explain you in more detail way how it will done, like that. So if these guys lost this private key here, this data you cannot retrieve it. See your OS. See, I will how they retrieved your data. This is your OS. Okay, like this is 100 GB. This got crashed. Okay, so here you have 400 GB. This is your data drive. This is encrypted. They will not encrypt your OS. Correct? Or they have encrypted this one also. Let's say if they encrypt this one, they will get lot of issues with OS. Booting will not happen. Booting will not happen correctly. They will get lot of issues. That's why what they will do, okay, don't encrypt C drive, encrypt the user data, D drive or E drive or F drive, whatever he will store. Okay, this encryption, all encrypted, will go back to BitLocker server. That will have all your keys. With every file, it will be that data integrity will be matched with that. Only if you provide the private key, then it will be opened. So this data, private keys, will be stored at one location with user specific.
So encryption policy will be set by security guys.
Yes, yes.
On the application.
Yes.
On
On user part, on user at user level, you will define that policy. Okay, so we need to ensure that the data is secured and we have the integrity of the data. Asymmetric, we have DSA, right? We saw in this one here, DSA, RSA and DSA, Def, Hellman, ECC, EL, GAML. So for database, we will use symmetric encryption. Okay, like you will mask your Aadhaar cards, right? Masking that Aadhaar card and retrieving it. They will use this symmetric encryption. If you want to retrieve it, then they will use this same symmetric encryption, which will be very faster.